So this is 1.5 part 2. So a composition function can be written either one of these ways. So these mean the same thing. So this is not fog, this is f of g of x. Or it can be written this way where it's f of g of x, where g is on the inside. So when we have a composition function, we start from the inside and go out. So looking at example 6 down here, we have f of g of x. So g is on the inside. So we are going to take the entire function g and plug it into the x in f. So because g is on the inside here, it goes inside f. So I'm going to plug in that whole function into the x. So I have 4 minus x squared plus 2. And then from here, we just simplify. So we're going to combine our like terms. I have negative x squared, and then 4 plus 2 would be plus 6. So this would be f of g of x. It says we have to find g of f of x. So this is different because it's in a different order. So we start with the one on the inside. So f is on the inside now. So I'm going to take my entire function f and put it in the x in g. So now I'm picking up f and putting it into the x in my other function. So here I have 4 minus, and then in that x spot, I'm going to put x plus 2 squared. So the entire function f is getting picked up and putting into g now. So we start with the inside, put that into the other function. And then from here we simplify. How can I simplify this? I have to FOIL out the x plus 2 squared. So this is like saying x plus 2 times x plus 2. So we have to FOIL. So it would be x squared plus 2x plus 2x plus 4. So we are FOILing. I'm going to combine my like terms inside that parentheses there. So I have x squared plus 4x plus 4. So just combine my like terms there. What do I have to do next? Distribute the negative. Awesome. So the negative gets distributed to everything in the parentheses behind it. So this is 4 minus x squared minus 4x minus 4. And now I can just combine my like terms, and I'm going to put it in standard form. So I start with the negative x squared minus 4x. And what is 4 minus 4? 0. They end up canceling each other out. So g of f of x is negative x squared minus 4x. So we want to find f of g of x, and if possible, find f of g of 2 and f of g of 0. So first we want to find f of g of x, and then we would plug in 2 and plug in 0. So let's start by just finding our composition function. So I'm going to start with which one? Which function is on the inside? G. So I start with g and plug that into the x in my f. So f of g of x is the square root of x minus 1. And then we would simplify if we can. Can I simplify this anymore? No. So then next it asks me to find f of g of 2. So I'm going to plug 2 into my x. So I have the square root of 2 minus 1, which would be the square root of 1. And what's the square root of 1? Just 1. So f of g of 2 is 1. Bless you. And then lastly, we have to find f of g of 0. So I'm going to plug in 0 into my f of g function. So that is 0 minus 1. 0 minus 1 would be negative 1. Can I take the square root of negative 1? No. Nope. So here it does not exist. We can't take the square root of a negative, so our answer would be it does not exist. So here it wants us to find f of g and g of f. So let's start with f of g. So which one's on the inside? G. So I'm going to take my function g and put it on the inside of f. So I have 2 times 1/2 x minus 3 plus 3. And now we want to simplify. So what can I do first to simplify? Distribute. What does the 2 get distributed to? Or what do I distribute first? I would distribute the 1/2 first since it's inside the parentheses. So 1/2 x minus 3/2 times 2 plus 3.
So for this first step, could we have canceled out the 2 and the 1/2?
Yeah. So next, what should I do? Distribute the 2. So here, if you notice, 2 times 1/2 is just 1. And 2 times 3/2 would just be 3. So from the start, we could have just canceled the 2 and the 1/2. We could have multiplied those together, and it would just be 1. So I have x minus 3 plus 3. And then I can combine my like terms, and what do I get? Just x. So f of g of x is just x. Bless you. Next, we want to find g of f of x. So which one is on the inside? F is on the inside now. So I'm going to take f and put it inside g. So I have 1/2. 2x plus 3 minus 3. What can I do first here? Cancel out the 3's. So plus 3 and minus 3 would cancel. So then I'm left with 1/2 times 2x. And 1/2 and 2 cancel out. They become 1. So this would just be x. So g of f of x is x. All right, the last thing we're going to talk about today is the domain. So to find the domain of a composite function. So it's a little bit different than the domain of a composition function that we did yesterday. When we find the domain of f of g of x, we always want to find the domain of the inside one. So we have to check the domain of g of x, and then we want to check the domain of the whole thing. So technically, our domain for f doesn't matter when we are finding the domain of the whole thing. So we just want to check our domain for g and our domain for the entire f of g of x. So there's 2 domains we have to do. Yesterday when we did it and we put them on a number line, we had to make sure all 3 overlapped. Here we just have to make sure the 2 lines overlap, and that's going to be our domain.
If you're finding f of g.
So we want to check the domain for the inside and the whole thing. So if it was flipped, if it was g of f, then we would check the f domain. All right, so let's start here by finding our composite function. Let's find f of g of x. So what's on the inside here? G. So I'm going to take G and plug it inside F. So here I would have the square root of 9 minus x squared minus 9. So I just took my function G and plugged it inside F. Now let's simplify. Yes.
Can you cancel out the square root?
Yep, perfect. So the squared and the square root cancel. So then here I'd be left with 9 minus x squared minus 9. What can I do next? Cancel out the 9's. So 9 minus 9 cancels. So then I'm just left with negative x squared. So this is my f of g of x function. Alright, so now to find the domain of a composite function, we have to check the inside. So we want to check the domain of g. And we want to find the domain of the whole thing. So the domain of f of g of x. Which one do you want to find first? It doesn't matter. Let's find the domain of g first. So g, I have a square root in here for our g function. I have to be careful whenever I have a square root. I have to be careful with the domain. What can I not have under the square root? A negative number. So how would I find my domain of g? Awesome. We set the inside greater than or equal to 0. Because our inside has to be greater than or equal to 0. It cannot be a negative number. So 9 minus x squared is greater than or equal to 0. And then from here we solve. So I'm going to add x squared to both sides. So we're solving for x. 9 is greater than or equal to x squared. What can I do next to solve for x? Square root. What do I have to remember to do when I take the square root of both sides? Plus or minus. So what's the square root of 9? Plus or minus 3. Perfect. So our domain of g is x is less than plus or minus 3. So since that's technically two numbers there, I'm going to put them on the number line just to see if I'm talking about the inside part or the outside part of plus or minus 3. So let's check. If I plug in 4, or negative 4, into my function, I have the square root of 9 minus negative 4 squared. So this would be 9 minus 16. Does this give me a positive number? No. So the outside part doesn't work. I can plug in 0 to check. So I have the square root of 9 minus 0 squared, which would be the square root of 9. Does that work? Yes. So the inside works. So in interval notation, we are talking about from negative 3 to 3, the inside part. Because also if you tried 4, that wouldn't work either. So we're talking about the inside part. Would I put brackets or parentheses here? Brackets, because it's including negative 3 and 3, because we have that greater than or equal to sign. So we put brackets. So that's our domain for G. Plug in 4. So if I have the square root of 9 minus 4 squared, that would be 9 minus 16, which is negative 7. So if we plug in 4, 4 and negative 4 don't work, so the outsides don't work. Yes, Caroline? All right, so that's our domain for g. Let's look at our domain for f of g of x. So here, f of g of x is negative x squared. Is there any value that I can't have for x? No, I could plug in whatever I wanted for x and square it and make it negative. So what do you think my domain is here? Negative infinity to infinity. So if I go back to my number line here, negative infinity to infinity would be everything. So where do my two lines overlap? From negative 3 to 3. So my domain for the whole function for f of g of x, the domain, is from negative 3 to 3. So it's where the domain of the inside and the domain of the whole thing overlap. So this would be our answer. So if we had a domain in the denominator, so this is just in general, if it was a composition or combination function, let's say I had a square root in the denominator, we would just want to set our denominator greater than 0 because it can't be that equal to also, because you can't have equal to 0 in the denominator. So remember, the two times we have to be careful with our domain is when we have a fraction and when we have a square root. So in your square root, whatever's on the inside has to be greater than or equal to 0. If it's a fraction, the denominator cannot be 0. And then to kind of just, so we know the difference of what we did yesterday and today. When you have a combination function, so if it's like adding or subtracting or dividing or multiplying, so f times g or f divided by g for one of these, to check the domain, we have to check f of x, g of x, and the whole thing. So whether it asks us for f plus, f minus, f times, f divided, we would have to check that. So you have to check 3 things when finding the domain of a combination function. So what we did yesterday. But when we have a composition function, so f of g, I'm going to change the color, f of g or g of f, we check the domain for the inside and the domain for the whole thing. So here we only have to check 2 domains and see what overlaps. And it's always the overlap.